Hey, good morning, everyone, or good evening. Um, I see we're 3 minutes from today's puzzle, Advent of Code Day 6. As always, we'll be solving them in F sharp. Seeing that we have 3 minutes to spare, when I was looking at my code from yesterday, I noticed a small inconsistency in the naming. So maybe that's a good warm up exercise to get the old fingers working. What was the thing I was not happy about? So this is the function that solves yesterday's problems, and there was a name I didn't like. What was it again? Oh yeah, so these are all the points, but they're not really just points. They're points counted, like how many occurrences we have. I don't like this line, this name actually. Okay, that's very small of a refactoring. It's the minimum amount of a warm up for my fingers. Oh, I'm just gonna call them counted points. There we go. That was the easiest of refactorings. Can I send this over just that file? Yeah, we can. That is not very intention revealing commit message, but I don't care. I've been taking a look also at the map. Yes, this map. I think we're tracking the sub. So we're currently at below sea level. There's some air bubbles. I always like the maps from Advent of Code, especially when you complete them and they're all animated. It's a really cool extra. There usually is always an Easter egg hidden in every puzzle, or at least last year there was. I don't think I've managed to find even a single one. No, I haven't found a single Easter egg in the puzzle descriptions yet. Let me know if you noticed something funny. Have I got my doodle stuff up and running? Yes, we do. Cool. Yesterday was the first day I needed to draw stuff. Geometry always trips me up. Geometry and grid operations, like running around in a 2D plane. I need to see it or my brain cannot handle it. 15 seconds away. Alright, day 6. Let's take a look. Lanternfish. The seafloor is getting steeper. Maybe the sleigh keys got carried this way. Are we still looking for sleigh keys? A massive school of glowing lanternfish swims past. Let's take a look at lanternfish. Is it the boss from Zelda? Not at all. I was expecting a fish with like a real lantern mounted on the head. Why are they called lanternfish? Bioluminescence, cool. Okay, so we see lanternfish. They must spawn quickly to reach such large numbers, maybe exponentially quickly. We should model their growth rate to be sure. That's actually recognizable. Like these stupid questions you have as a programmer, and you start hacking away to get an idea of a number or something. Although you know nothing about this specific species of lanternfish, you make some guesses about their attributes. Surely, each lanternfish creates a new lanternfish once every 7 days. However, this process is not necessarily synchronized between every fish. One fish might have 2 days left until it creates another fish, while another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new fish. Yeah, sure. Furthermore, you reason a new fish would surely need slightly longer before it's capable of producing more fish. 2 more days for its first cycle. So usually it takes 7, but they need to grow up first. So that's 2 more days. Yeah. Suppose we have a fish with an internal timer of 3. An adult lanternfish, probably. So it only needs 7 days. It's ticking down to 3. It's ticking down, it's ticking down. So this is the after day 1, 2, 3. Yeah, on day 4, when we loop around, it resets to 6. It takes 7 days, cool, I get that, but then we talk about 6 and 0. Don't like that. But okay, we'll follow that, or it'll be really mentally intensive to keep mapping between the way we model it and the way the example models it. It's okay, when we reach 0... No, actually, when we reach 6, we spawn a new fish. And the first time it resets to 7 and 2, so 9 or 8 days. Cool. After another day, the first lanternfish would have an internal timer of 5, and the new fish has a timer of 7. Yep. A fish that creates a new fish resets its timer to 6, not 7, because 0 is included as a valid timer value. Yeah, that's a weird implementation detail that is leaking into the puzzle description, but okay. The new fish starts with an internal timer of 8 and does not start counting down until the next day. Yep, that also makes sense. The submarine automatically produces a list of the ages of several hundred nearby lanternfish. Okay, so we have the ages. Are they all below 6? Or do we have weird numbers? No, they're all below 6. Cool. I'm going to drop this into my input already. Let's close day 5 before we make any horrible mistakes. How many fish do we have? 100? I thought we had 100. Why is it... Yeah, character 600. That's not 100. That's more like 300 fish. Okay. So we have internal fish timers for a couple of hundred fish. And those are just the internal timers. Yes, that makes sense. And this is a simulation for the example. So let's grab the example. This is the correct value. What's happening? I'm already not finding my way. That's a good start. Yep, that looks correct. Each day a 0 becomes a 6 and adds a new 8 to the end of the list, while each other number decreases by 1 if it was present at the start of the day. If it was present at the start of the day. Yeah, okay, makes sense. In this example, after 18 days, there are a total of 26 fish. So that's the number of internal timers, yeah. After 80 days, we would have a total of... Find a way to simulate fish. How many fish would there be after 80 days? So for a small example containing 1, 2, 3, 4, 5, we rise exponentially to 6,000. That's like... Yeah, that grows fast. I'm thinking, should we do the naive thing first? Probably it'll work for part 1. Probably it'll burn my CPU for part 2. But I don't see... Actually, I do see a way to make this easier. We don't need to literally keep track of every fish. We can also keep track of a timer or an internal timer representation and the number of fish that it represents. So instead of having 3 7s in a list, we can have this timer 7 and the count of 3 in there. And then we only need to work with 8 numbers max, or 8 different timers and a couple of numbers. That actually sounds like a good idea to do for the first part already. No? I think so. So let's do it that way from the start. No. Actually, yeah. The only problem we have is we can't really check our implementation with this example. Is it important that new fish end up in the end of the list? Not for part 1 at least. Maybe for part 2. What are we going to do? try to optimize and hope part 2 evolves in the right direction, or just do the naive thing and go with it until it crashes. Let's do that and then refactor to the optimal thing. So we're gonna just do a naive list-based approach as we see here. What do we need to do? We need to parse our fishes. That's going to be easy today. So it's just going to split on a comma. And we are going to map on to an end. Let's just try parsing something. Yeah, you're right. We don't need to actually split anything for the example today or for the real input. 34312, that is correct. Just going to drop it in there. 34312. Yep. Let's try to parse our actual input to make sure we don't have any problems. 141 da 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 da. 142, I mean. 142, yeah, okay. We can parse the string. Thank God. So, if we are going to do the naive thing, I am thinking, how should we implement this? Just by using recursion and checking how many numbers we put? Or should we do something fancy and use a not so often used function in the list or sequence module called unfold? Maybe it's cool to show unfold. Oh, what does unfold do? It returns a list. We are looking for like a sequence of generations that contains elements generated by a given computation. The given initial state argument is passed to the generator. So we give it an initial state, a function that generates the next generation of a fish. And that's it. It generates like a list up until where we want it to. The way it knows when to stop is with an option. So as long as that generator keeps returning sums, we can generate this list. And if we use sequence.unfold instead of list.unfold, we have like a lazy evaluatable list. So we can just write the generator and take as many as we want. So I think this will be a nice fit for today's problem. We're going to unfold. Folding reduces a list to a single state. Unfolding starts from a single state and generates a list. So 2 things we need to worry about in that case. One is the initial state, but I think that is already just our raw fish list, because we will not be doing any optimizations. I'm going to call that gen 0, generation 0. 34312, yeah. So that's our initial state, and then we need a next generation function, not sponsored by the way. Next generation, and it takes a state, so that's a generation. Actually, no. Unfold takes a state. Yeah, and it returns. Yeah, it's good. We're good, sorry. So it takes a state and it returns a tuple of an element in the list and a state. Do we need to have a different element type and a different state type? No, I think we can do both. So some generation and generation. So this will create an infinite list containing just the first generation just about now. Let's see if that works. So we start an unfold with the next generation and we provide the initial state. I'm looking at the signature, and it's saying unfold takes a generator and a state. I don't see the return type in that type signature. That's confusing and weird. What does it return? Why is there no return type here? Oh, there it is. Sequence of T. Yeah. Okay. Okay, types line up, so that should work. So we catch that and we say take a couple of generations. That should also work and not crash. Yeah, that works and does not crash. So now the only thing we need to do is take a look at the next generation function. Next generation just ticks down all the fish we have, right? Right. And we should do a modulo. If we reach 0, we should go back to 6. Right? If we should reach 0, we should go back to 6, yes? And it's the fish that do this. If it resets something to 6, we create a new fish. So every fish with a 0 builds a new fish, and the new fish is an 8. Okay, so let's find the soon-to-be parents. So parents are, let's call them number of parents, is the generation. Let's just use a filter where we have zeros. Those are the parents. And we don't need the parents, we need the amount of parents. So every fish that is a 0 will spawn a fish. Yeah, and now we just transform every existing fish into the next one. So that is the current generation. We map over it with a plus or minus 1. Yep. So every time it ticks down, and then we just append as next, and we append something. And what we append is a number of 8 fishes, and the number is number of parents. So I think you can do something like, how do you create a list and you know it's all the same element? Replicate, something like that, I think. List.replicate. You give it a count, an initial state, and it gives you a state containing that initial value that many times. Let's see, we don't mix up our positions here. First, the count, so that's the number of parents, and second, the element that is a new fish. I already regret not doing the optimization. And we just keep going, so we just always provide a sum. We never stop the unfold. I think this will kind of work. Let's take a single generation. Uh-oh. Interesting. Oh, we do 1 minus? Yeah, we do the different thing. I was trying to be too clever. So we should do number minus 1, not 1 minus the number. I did the same thing here for the equals check, but equals is, you can switch positions, so that would probably work. 2, 3, 2, 0, 1. 2, 3, 2, 0, 1. Yeah. Okay, so let's take, how many should we take after 18 days? So let's take 18 of those. Let's print those out really quick. So print out whatever. Let's take a look at those 18 generations. Thus, there's a match. No, I see 0. Of course, we shouldn't decrease parents. We should reset them. I don't know how I forgot that, but if n equals 0, then that becomes a 6. So they loop, and otherwise we go 1 down. What is that actually? I was thinking, can we do modulus? Probably we can, but I don't really care. That won't be where the problem is. 606, 8888. Let's put those side by side. Sorry, this is side by side. 606, 456, 01126, so blub 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 67. That looks correct actually. So after 80 days, how many fish do we have? Let's count. Sorry, we take the 18th. So nth. And then we take the number of fish. 6538. Wait. So for 18, does that work? And why is nth giving me green squiggly lines? This construct is deprecated. Please use item. Oh yeah, I've short made all the modules that do stuff with collections have like more similar behavior. They used to have subtle differences, which was a bad idea anyway. So this is an improvement. 29. 29? No. Am I off by 1? Of course I'm off by 1. A list or a sequence is indexed by 1, so we should take 17, right? 26, yes. So wanted generation is 18, and then here we should take the wanted generation minus 1. So this makes it a bit more clear what we're doing here. 26 is for day 18, and for day 80 we should have 5934. 5934. Oh, that works. It'll probably blow the CPU though. So that's actually pretty decent. So the naive algorithm, I think we have it down. Let's try it to run it. Whoa, okay. Just like overlaying text, the type int is, is moving slower than the speed of my fingers. Yeah, so parse the initial. Parse the initial generation. Actually, why is it? Oh yeah, because we need an equal sign. Okay, so we parse the initial generation. We create a sequence of all the generations, and we ask for a generation. And then we just take that generation out of the sequence, and that lazily evaluates all the things until we get there, and we just count the number of fish. Yeah. So this should give us the 5934. It does. Let's hard code that in a test. 5934. We need to specify the generation we want, of course. That was 80, right? That was 80. Cool. Let's see what this does for our input. Let's also quickly start a timer because I have the nagging feeling that this naive approach might just take a while. Not too bad, actually. Part 2 might be more interesting. That is part 1 down. Congrats to us all. Part 2. Suppose the fish live forever and have unlimited food and space. Would they take over the entire ocean? That's funny. So fish live forever. So our whole optimization strategy we're figuring out is useless. They have no age anymore. Yeah, this is an interesting twist, actually. This was not the twist I was thinking about. Shows to tell that trying to predict the future, also when you're writing products or writing software. Predicting the future if you have zero information about the future is a silly thing to do, and most often than not, you are incorrect and have wasted money or made the design more complicated than it should be. So handle predicting the future with a bit of care. Anyway, how will we solve part 2? Oh no, actually, it is literally what we thought about. They just never die, but they didn't die in the first example. They just have a, they just have a, like a 6-day or 7-day cycle. That's still the case. Forget everything I said about predicting the future. We predicted the future. Yeah, so after 256 days, for giggles, I'm going to try it for the example and watch my CPU burn. This is a big number, right? Is this something that fits into an integer? Because otherwise we will even have problems with sequence.length. I'm actually not sure. This looks like a big number. I forgot how much an integer is. Is an integer 32-bit? Let's look it up. So this is the size of an integer. 1, 2, 3, 1, 2, 3, 1, 2, 3. We're getting close, right? Only a factor of 10, 20, and we hit it. And if you look at what was our solution again? For part 1, 350,000. That is already a lot bigger than the 5,000 from the example. I think maybe even sequence.length might not really work. That is actually interesting. But all that aside, I think we can do the optimization because our... Is this still going? Yeah, it's still going. So let's reset it. We won't get anywhere. This is even for the small example, and our initial generation for the real input is way bigger, so this will not work. So I just suggest we do a quick refactoring to the design we discussed before we started coding, which is, instead of tracking every fish individually, we keep track of the different timers we have, so the different ages that can exist, and we just keep a count of how many fish have reached that phase in the cycle. So what will change? Not a whole lot, because we don't have a whole lot of code, but what will change? Next generation will not work on lists as it is working here, so instead of just parsing the first generation, we might want to make that smarter. So let's type it out. Now we have a int list. To be, we want to have a timer and number of fish kind of list, or lookup table even. Do we need to look up timers? Yeah, we only have 8 of them, so it's not really a performance issue. But anyway, let's make it a map. So we map timers to the numbers of fish. Actually, a map is not really useful because all the fish will move from one generation to the next. Yeah, all fish will move. Well, what would be the best data structure here? What do we need to do with this thing? Need to grab the zeros. That is easier with a map. Then we need to move everything. That is just as easy with a map as it is with a dictionary. We need to add new tiny babies. 8 babies. Let's do a list first. I don't see it happening with a map in my head just now. So yeah. I'm going to make a data structure of this because they're both numbers. Probably one of the numbers will... No, both of these numbers will probably be okay to stay in the int world. Maybe the number... Oh, no, actually. This divides the entire list length by 9. So we might have that factor of 10. We might like just straddle the integer boundary. Let's try it. So yeah, I'm going to define a type. State, and state is a list of... What is a timer and a fish called? Timer counts? Let's do timer counts. That is a really weird name, but if we declare that type, timer count is a timer and the number of fish that have that timer. So let's make generation 0 a timer or state. How do we transform a list of numbers to a list of timer counts? We group by the age, or by the timer, sorry. And the number of fish is just the amount of digit or numbers we have. Yep, let's go. Should we do that in the parsing or in the solving? I'm in favor of doing this in the parsing, actually. For me, this is still parser world stuff. Maybe not. Maybe parsing is... Depends on how you look at it, I guess. I'm gonna do it in parsing anyway. So the thing we have up until now is all the timers, and then we want to do something. We want to group them by their timer value itself, and then we want to map each of those groups. What is this group actually? It's a sequence. No, it's a tuple of an int and a sequence of ints. Yeah. So it's actually the number representing the timer, and fishes is a list of every fish that has that timer. So we just need to take a look at the length of this list. So the timer is the timer itself, and the number of fish is actually the length of the fishes list. Yeah, I think that works. Let's try that. And because we crashed, we need to reload our FS interactive window. Let's take a look at this. We have 2 fishes with timer 3. That is really incorrect. What? Oh no, we have 2 fishes with timer 3, one of 4, one of 1, and one of 2. That is correct. I'm gonna explicitly have the return type here be state. Yeah, I'm gonna have an explicit state, so the type signatures flow out to the rest of the code. Our parsing now returns state, so everything that uses input from our output from our parser will need to be able to work with state stuff. So next up, we changed our data structure to hopefully handle part 2 a bit better than burning up my CPU. Next step is to update this next generation function so it works on that new data structure instead of on just a plain old list. So I'm just gonna keep breaking everything. Compiler is still in a non-compiling phase, so I'm just gonna soldier on ahead. How do you figure out the parents? That's actually easier now, right? When we have a list of timer counts, we just need to look up for the timer count for that are timer 0. Now that I say this, maybe a map makes more sense actually. So at least we don't have the duplicate entries thing. Have I just convinced myself to use a map? I think we have. Let's just give it a try. So instead of a flat list, we have a map mapping timers to fish, but then our timer count is not really relevant. So be it. So we have a map mapping timers to fish counts. They're both integers for now. I don't think actually that the way I use this type alias right now, I don't think this will actually help us in any way, because you can still swap, I think, timers and fish counts accidentally and it'll all compile. Let's see if that is actually true. So let's say X or timer is a timer and that's just whatever. And let's say F is a fish count and that's something else. Let's try putting that in a map. So timer fish count map of sequence. So now we build a map and let's type that as a state. Just doing some little experimenting here. So that works, but what happens if we swap fish and timer? Yeah, that also works. So actually introducing these types provides us no value, except if you do this. So we make a single case discriminated union type. And now you have to specify, actually here you have to specify, hey, by the way, it's this timer case, and here it's this fish count case. It's overkill. It's complete overkill, but now at least you get compile errors when you accidentally swap a timer and a fish. So yeah, this compiles, the other way around does not compile. Well, I kind of like it. I'm gonna keep it. So instead of doing this, we just have a tuple of timers and fish counts. Something like this. Let's maybe put some parentheses around that. And it's not an object, that's more of a tuple. There we go. So our parsing now parses into a lookup table or a map, and then everything else will flow out a bit nicer, I think. Let's give it a try. So the parents are the number of parents. That's even easier. It's a map lookup on generation. And we look for timer 0. And we have, this is actually a fish count, right? Yeah, fish count, sorry. So if we say it's fish count number parents, we destructure, then we have the integer value, and that works, yeah. Shifting to the next generation, that will be a bit more interesting, because now we have to move everything in the map down a generation. It's mapping timers to fish counts, and now we have to move the number of fish counts to the bucket of a timer lower. We could just actually, can we do something like map.map? Is there a map function for a map? You can do map.map. That looks a bit weird. It maps a mapping And the mapping itself takes a key and a value, and it returns a new value. That's actually not what we want. We no. We also want to have a new key, right? Or we want to move elements in a map to a new key at least. Yeah, so let's, for this step in the process, having a map is not really useful. Hopefully this won't be too much of a performance hit to convert that map again. To a list again, I mean. So now we get rid of the map structure, so already maybe a map is not the best data structure, but it's only, what, 8 elements, so let's not worry too much. So we map it, and then that is the timer and the fish count. So if we reach 0, then if this is the group of fishes that have timer 0, then this has to become the group of fishes that have timer 6. And otherwise the timer ticks down. Actually, we only need to do something with the timer, right? Yeah, so the fish count can stay. Yeah, I'm regretting my map decision a little bit, but let's soldier on ahead. So the new thing becomes timer 6 with the existing fish count, and otherwise we just tick down, so it becomes timer -1 and the collection of fish. And to stay in line, oh no, we also have to add the generation 8. So that is a new tuple of timer 8s with fish count. Oh, sorry. Yeah, still correct. Sorry. With fish count, number parents, I guess. I think so. So this is the next generation, or the new fishes. We won't have a timer 8 in there because we take everything down and 8 is the max. So yeah. The full next generation is all the next fishes and the new fishes. Let's just put that in front of the list so we don't have to do something crazy. And let's put that in a map again. So already I don't know if a map is a good thing. Why is there a squiggly here? Okay, there was a squiggly for no reason. Compiler is happy. But the parser or the... Oh yeah, we changed the parser type or the output type, so of course our tests break. Let's take a quick look because I was on autopilot and may have introduced a couple of bugs here. Or maybe if we just run the test, we'll figure that out as well. So let's see what the parse does now. 1 fish for timer 1, 1 fish for timer 2, 2 fish for timer 3, 1 for 4. That is correct. Can you do? I see like in this printout, you can, it's like map space and then a list. Is there a function called map? No, there's not. There's a map of sequence, so we'll use that one. That's the one I know. Thanks, auto formatter. If it works, it's amazing. Let's grab this nugget import and put it closer to where we need it. That appears to still work. Oh yeah, of course the parsing works, but does the solving work? That is another question. Of course not. Key not found. Key not found. That's a bug I wasn't expecting. So solve. What does we do here? We parse into that state type. We do an unfold. Then we say take that generation. Sequence.length is not what we want to do though, because that will just always be 8 or 9 because of those different buckets. So we have to do a different reduce here. But the fact that it crashes is a bit scary because that was something I did not expect to go wrong. What are we doing? Map.find, and that is failing. So this is not working. Can there be a tick where we have no fishes reaching breeding age? Yes, probably. So this map.find is actually a bug. We don't always have something. Or if we do, maybe we can do it that way. Like keep, instead of having the entry timer 0 not in the map, we can have the entry 0 in the map, but have a fish count of 0 in there. Now that I'm saying this out loud, that actually makes more sense than... That actually makes a lot of sense. How will that design decision impact the code? So instead of doing this and just blindly... No, you know what? I'm going to do it a bit differently. And I'm going to do a try find. So our design decision will be... we try to look up the timer zeros, and it's not always going to be there, and that's something we know and live with. So generation, try to find the number of fish that have that time has run out for the cycle, or if we don't find anything, we have a fish count of 0. So instead of having that entry timer 0 in our map, we just have it in the business logic here. So if we try to look it up, if we don't find it, we will just assume that the fish count is 0. Yeah, I'm happy with it. So we'll still have a wrong answer, but I hope it does not crash anymore now. The answer we're calling is 1098, something like that. Yeah, 9. Okay, so we know what is wrong. The sequence.length thing is wrong. Sequence.item returns a map. So this is a map, which is implicitly a sequence as well. So we can do a sequence.map over that map. That's becoming confusing to say out loud. And this has a timer we don't care about. Fish count. So we just extract the fish counts. It's not working. Why is it not working? Oh, it is actually implicitly a key value pair. Don't like that. Let's get rid of that map. Let's make it an explicit list. And then we do have tuples. 2 lists, sorry. Or 2 sequence, whatever. This maps it to the fish counts, and then we need to sum them. And if you want to do a map followed by a sum, I hope we can do a sum by, and that will lead to the same result. Let's grab everything and send it to le REPL and see whether or not it still works. No, it's actually worse. Is sum by not doing what I think it's doing? Yeah, let's see first if sum by is not doing what I think it's doing. I thought map followed by sum always can be replaced by sum by. Okay, it actually can. So we have another bug. What is the bug? Don't see it. So let's start printing out for the small example. Okay, let's alias next to be the example. If you do that, you can just select text that uses, oh no, you have to name it text, not next. If you send this to the REPL and you just select some text that uses that, or some code that uses that text variable, you can just execute it and see what happens in the REPL. Yeah, so we already validated this. We have generations, so let's now play around with it a bit. The first generation, what should that look like? We have one fish at 0, two fish at 2. Yep, one fish at 1, and one fish at 3. And already a fish at 8. No, 0 fish at 8. Is that actually correct? It is correct that we have 0 fish at 8. I know why it's there. It's because of that option or def value thing right here on line 23. But it's confusing because that's not what the output is showing. We have like a timer 8, but it's a 0, so okay. Let's not worry too much about it. This still looks correct. Let's see what the next generation will tell us. Timer 0, we do have a fish with timer 0. That is true. We have 2 fish timed 1. Yes. We have 1 fish timed 2. Yes. We have 1 fish timed 6. And 1 fish timed 8. Do we have a fish timed 8? This looks correct, right? Let's go to 18 to make sure. I'm not seeing the problem right now. Maybe the problem surfaces somewhere later. Oh no, now we have to do actual mental gymnastics. 1, 2, 3, 4 new fishes. Interesting. Interesting. There is a problem, but it's a surprise to me, so I'm a bit lost. I'm just gonna print out every generation and yeah, we will figure it out that way. So we'll take the nth item, but before we do that, let's print out a generation. If you're working with reactive kind of things like sequence or collection pipelines, having this kind of trick in your bat belt helps. So map over it, but just do a stupid function that has a side effect of printing and returns the value. So it's an identity function with a side effect. And most of the reactive extensions, JavaScript stuff has like a debug kind of function. That's literally what it does. So now we print out every generation before we process it. Let's see what this does for our little example. Can we print it out a bit better than this? I don't care. So this is after 18 days. Let's run our code for 18 days of the example. Yeah, I'm gonna print it out a bit nicer. So timer, fish count as the generation, and now we should be able to no. Oh yeah. Never mind. We'll make do with this syntax. Initial state we don't print out, so this is the first thing we see. 2, 3, 2 twos, and 1 of everything else. and no bebe. You know what? If we don't have a new bebe, let's not add a new bebe. So if we don't have, yeah, this is the new fishes. Let's not do that part if we don't have any parents. So this is where we use it. Let's make an if statement here. If new fish number parents equals 0, then we just return next. Otherwise, we do have parents. Then we do the new fishes thing. And let's just take that new fishes thing, plop that in there literally. Okay, we print that now. We should not have that confusing 80 thingy in there. Where is the bug? Where is the bug? Chat, if you see the bug, you could help me out here today. So we have I'm also going to print out the generation because it's confusing me. So we print out the index and yeah, that's the generation, but it's offset by 1. So generation this is this, and the generation is the index plus 1. Let's try that one more time. Generation 18. Okay, this is a bit more help. Generation 1 looks correct. Generation 2. 23201. 8. Huh? What? Yeah, actually, it's correct. Yeah, there is an 8. Sorry. I was confused by the initial state being on the top here. So yeah, generation 2 has 1 fish times 0, 2 fish times 1, 2 fish, no, 1 fish times 2, is that correct? Yes. And then we have a 6 and an 8. Still correct, still don't see a problem. How is this possible? Let's go to a generation that has multiple children. 11. Oh, let me just select one line. Okay, thank you. This is generation 11. 1, 2, 0 fishes. It appears to not be correct. Here we have only 1 fish with timer 0. And here I see 1, 2 fish times 0. Okay, so the bug here has happened already. Okay, let's go back a couple of generations until we spot it. In generation 10, we have 1 fish with timer 0. That's also incorrect. 9. 9 might be still correct. 1 fish times 0. 1 fish times 0. Let's take a look at the cases where we have multiple zeros. So after 3 days, here it's still correct. We have 2 fishes with timer 0. What's so special about day 10? Let's take a look at day 9 first. Day 9 is giving us 1 fish times 0, and that evolves to 1 fish times 1 fish times 1, sorry, and that also evolves to 1 fish times 0. Yeah, makes sense. But then in generation 11, no, in generation 10 we should have. Oh, there's already a bug in day 9. We count 1, 2, 3 fish, or 3 number 1s. And here we have 1 fish number 1. That's also a problem. So it's not only 0 stuff. Cool. How many number 2s do we have in generation 8? 1, 2, 3. Yep, also not correct. Generation 7, how many 3s do we have? 1, 2, 3. Yep, so we should have 3 4s in the next generation. That is also a bug, yep. We should have 5s in this generation. We always also have 1. Okay, we're getting closer to the actual bug, I think. So we should have 3 6s in day 4. We should have... Yeah, that's where the problems start. I think so. After 4 days, we should have 1, 2, 3 6s. And we only have 1 in our code. Where do these 6s come from? 1 comes from a... Where do these 6s come from? That's a... Oh yeah, it's the zeros looping around. Of course, the bug will be in the looping around. So 6s. Zeros become 6s, and that's where they enter the fray. Do we do that, actually? Oh. Oh. Ooh, I think I already know the problem. No, I don't. Yes, we do. I'm using a map. Map is like a key value store, mapping a single key to a single value. But we have 2 ways where we can have the key 6. One is by counting down. And the other is... Come on, brain. Why are you blanking on me? I thought I had it. So we can come from above the generation... Yeah. We can have a generation 7 that ticks down to a generation 6. And we can have a generation 0 that cycles and becomes a 6. And if I do this thing here, going to a list and then back to a map, that actually will only use one of those 2. So it's a destructive update. That's the bug. And that's a really tricky bug to figure out, actually. Took us, what? A couple of minutes? How do we fix this? Actually, we can do a bit of after-the-fact massaging. It's not the cleanest of... It's not the cleanest of approaches, but it might work. So I think if we print out this next, we sometimes have 2 6 timers. I've seen people do advent of code in Kotlin and other programming languages, and they are heavy on the types, but not only defining types, but also defining like behavior on types. I think if we went down that route, it would have been easier, because now we don't have a place to put this behavior except in this major function. But anyway, we know the bug, probablement it's that. I'm thinking, should we get rid of the map, because that is what allowed the bug to exist? Yeah, let's get rid of the map. Actually, no, we're doing 2 things at the same time. Let's first bug fix and then get rid of the map. Even though the map was part of the problem? Yes, even though the map was part of the problem. So, this is everything ticking down. No, yeah, it's everything ticking down, but we have like potentially 2 number 6s. Should we go through a lot of hoops? Yeah, we should go through a lot of hoops. So let's group by timers. And let's reduce that. So if we have multiple groups of timer 6, for example, which is the only problem we have right now, we sum up all the fish counts. So it's a bit of a reduction or a summation based on the timer we have. So if we group that list by timer, we now have like a list of groups, and for every list of groups we can reduce back to a single value. So that is a sequence.map group. What was that again? Sequence of keys and elements. So it's actually the timer and the other things. I have no name for this concept. So we should return timer and fish count. No. Sorry. Let's see the type in action again. This is a, oh, it's a sequence, and it's a list, not a sequence. That's the problem. So let's stay in the list world. Then this will work. Yes. Now the only thing that's a problem is this foo, which is a list of timer fish counts. So we have to reduce that list to a single number. Yeah, I'm just gonna put that in a separate function because it's non-trivial. Trivial aggregate. So yeah, here we can do the foo list dot reduce. Reduce will crash with an empty list. So let's do aggregate. Don't like this name. It's already hinting that this is way too complex. So here we go. That's the last problem to fix, hopefully. This is a list of timer fish counts, and we want a single timer fish count that represents that timer, but the sum of fish counts. Will we ever have a problem with there not being an element? No, actually don't. Let's just use a reduce, yeah. Reduce takes 2 elements, right? Takes 2 elements. So let's call it one and other. Yeah, of course. Yeah, you know what? Actually, we don't need this timer here. We can just do an entire aggregate of the group. We can do an entire aggregate of the group, and then we just can do a list.reduce, which takes 2 of those fish count timer tuples, and that will work actually. So let's do timer or t and fish count 1, and this has another or an identical timer. We don't care about that one because it should be the same, and it has fish count other. And the thing we want to return is that timer, which should be the same for both cases, and fish count 1 plus the other. And that will work for a non-empty list, hopefully. What is not okay here? A lot of parentheses. Yeah, should work with this. What's not okay here? Let me quickly put this into comments again. Yeah, that is the problem. What's wrong with this line of code? It's a parentheses thing. Okay, we miss a parenthesis. Yeah. And fish count is a very difficult word to type. Do I like what I'm seeing? Not at all. It started out somewhat readable, but now this main loop is terrible. But let's see if it works. $26 for 18 generations. That looks like it's okay again. Let's see what 80 generations gives us. 5934, yo, we're there. So let's not print out anymore. Where's our debug statement? This should, our test should still be green. Right, right. Let's see if we can get to 256 days for the example. Nope. Arithmetic operation resulted in an overflow. Which arithmetic operation resulted in an overflow, though? That is the least helpful exception I have ever seen in my life. It's just saying, hey friend, dear friend, you have an overflow somewhere in your application. I won't tell you where. That would be too helpful. Where could this thing be overflowing? Here? Some by? Let's see. Or maybe this plus, one plus other. Let's see how far we get. If we don't do the end step. Oh no, it actually works, so it's the sum by that fails. That's actually easy. No, we have overflows all over the place. Minus, 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 minus. Let's migrate into the world of longs. Timer can be an int, sure. Fish counts, there have to be something else. Let's grab, what is the bigger type? Int 64? I think so. What is this thing doing again? Oh yeah, that's just parsing. That will work. How do you represent a long? Is it the le? No, I don't know what the syntax is for an inline long. What is it again? Let's see. What calling our function returns. We should also do a. Yeah, it is an L. Oh yeah, it's because we commented out this line. So that should be let's make it an explicit long. Apparently having it as an int also works, which is confusing. Let's see that in action. Does it work if I provide an integer as a long? Yeah, it does. The only thing we did now is change a single line of code, making this a long. Is that enough to solve the problem? Maybe. I want to check one more thing before I... Oh no, actually, we don't have to do that. We can compare this to the actual example answer we have. 269539. That is correct. But le question jambon, main question, will this smarty ass approach work for the real input? We get a number. It looks like a possible number. Let's see. Oh, I'm happy. Or at least I'm happy that we solved today's puzzle. What threw me off today? Yeah, again, a bug in the thinking. It's 2 days in a row that code is not the hard part. Or yeah, it was a bit harder because of this hidden behavior of a map when you have duplicate entries or duplicate key values. But I didn't think about the case where you have timer 6 can come in from both directions, from a wraparound and from a new generation that is ticking down. Can we clean this up somehow? I'm gonna get rid of the debugging. How fast is our solver actually? Oh, it's super fast. I'm really happy that we figured out the optimization ourselves. Do I want to do a cleanup of this monstrosity? Let's go over it with a fresh pair of eyes. We have timers, we have fish counts, we have a map, or our state is like modeled as a lookup table. Our parsing returns a map. In hindsight, maybe I should have done the conversion in a different place. No, in hindsight it's okay. Fish counts are longs because that bit us. Next generation is the only interesting part because we use an unfold. I love it when you use collection functions and like all the things like for loops, while loops, if statements, they all disappear into the night. Or at least until you see this monster of a function. What do we do in this function to calculate the next generation? We grab the count of fishes that will spawn offspring by looking up timer 0. And if we don't find it, we just continue with a count of 0. That's okay, actually. Don't mind. Then we have this little aggregation function. That's what I mentioned. If I would do this in C# or something else, this behavior would migrate more towards the data types they work on. So let's maybe put that here. What is this actually? We don't have an explicit type for the... Let's make an explicit type for that. So a timer and a fish count. What is that? What is a timer and a fish count? That's the foo we mentioned a while ago, yeah? We don't have a term for this. Counted timer. I hate the name already. Can I specify this map in terms of this counted timer? I don't know. I don't think so. That would be even more explicit, but okay. So this takes a list of counted timers and it returns a single counted timer. Okay, so this has moved to the counted timer module. I'm happy enough with that. Let's call it reduce actually. What happens if we do list.reduce? So if we do the actual reduce call here and call this function like reducer, if this would be in a real code base, I would put stuff in modules and then you would have like something like counted timer dot reduce. That makes more sense, but oh, it's not working. Cool. What? It's a list of timer and fish counts. And timer and fish count should be a counted timer. Why is this not working? Let's Control Z out of it. That's a timer and fish count list. This is a counted timer list. Is that a problem? Let's see if that is the problem. Oh, that was the problem. No? Oh yeah, the type signature changes, of course. Ugh. Do I want to? Yeah, I want to. We are refactoring, so let's play around with it. Do I like what I'm seeing here? The reducer takes 2 counted timers and returns a counted timer. Yeah, actually that makes sense. Can we type this as a counted timer? That's a really weird syntax to be taking a look at. I've never seen this in actual code, I think. It's not very readable either. But I do like having the counted timer type appear in the function signature. You hover over it somewhere, you see it's no, it's actually not. I would expect it to show count a timer, count a timer, count a timer. That is interesting. Why is it not doing that? Anyway, we tried, we failed, so let's get rid of that part. Cool. Okay, so we got rid of a little bit of inner function that belongs to the count timer stuff. Should we do something else with this code? This also looks a bit weird. It's not like a clean pipeline. It's a clean pipeline broken with this logic. What is this logic doing? That's ticking down a timer, right? That is ticking down the timer. It keeps the fish count as is, but it ticks down the timer. So let's extract it into its own function. So we have a function tick down, which takes a timer. And that's literally this part, or at least for the timer stuff. So if timer t is 0, then return timer 6. Otherwise, return timer t minus 1. And I should really be running my tests, so I'll do that in a second. So yeah, this maps a timer and a fish count to tick down the timer and keep the fish count as is. Let's make those names a bit more self-explanatory. There we go. Do I like what I'm seeing? It's not a clean function call. We dig into the type a bit so we don't drag along the fish count. But it makes sense when we're doing tick down logic. We don't need to know about fish counts, do we? Let's run our tests really quickly. Our tests are like 2 tests, so it's not that big of a deal. Okay, we are still green. Are we still green for the huge thing? 1.5 something something. Oh, 1.5 something something. Yeah, okay, looks good. Let's maybe also put that in there as a test, so we don't have to go look every time. But I think we're almost done. Cool. So parsing, yeah, we were working on next generation. That's clean. That is cleaner now. This is handling the new parents. If you don't have any, that's it. Otherwise, we append the new children. I'm not gonna extract that. That's okay. And then just return it. I'm actually happy our code fits on the screen again, or at least almost. I don't see anything too surprising, too hacky. Only thing I am not 100% sure of is the data structure again, because we use it only once, that's here, to grab the timer 0 fishes, and then we say goodbye map data structure. I will be using a list now, so that's and in the end we go back from a list to a map, so I'm not really happy with that. But that's enough waffling. We solved it, we refactored it. It makes sense to me again. The only, maybe, what was the bug? I had this reduce thing. That's, if I look at this 2 weeks from now, I will be all confused. So let's add a comment in there. I don't write that many comments, not even on my day job, but here it warrants a comment. 6 can enter the fray in multiple ways. So we need to add those together. First way, 7 fish turning 6. Other second way, 0 fish turning 6. So that was the bug we had with a little comment. So gonna check that in. Boink, push it. I'm happy. We even refactored today's code. We're 1.5 hours in, so it's a bit longer than I hoped, but I had a lot of fun. And I hope all of you had fun as well. I will see you tomorrow for day 7 of Advent of Code. Thanks for watching. Bye-bye.